So as you can see, I've been fooling around with mounting the supercharger itself in the Datsun. But one of the main things that it's going to come down to is this right here. I've taken a serpentine pulley from the same year of Magnum motor, cut it up a little bit, made a little bit of modification on the lathe in order for it to fit the regular old V-belt pulleys that are on the engine itself, so that I will end up with a supercharger pulley behind the V-belt. It's seems a little small. I don't believe it's an underdrive pulley, but it seems a little bit small. But with a measured diameter of about 5.7 inches, and then the existing supercharger pulley that's right around 3 1/3, we end up with a drive ratio of 1.71 between the two pulleys, and that coupled with the internal step-up ratio of 354 will give us an effective drive ratio of about 6.1 to 1. So roughly, when the engine is spinning 6,000 RPM, we'll be just over 36,000 RPM. I do need to double check the maximum impeller speed on this old supercharger. I believe I want to say it's 42,000, so we'll be well within the operating range of the supercharger itself. It just remains to be seen how much boost we will get at roughly 36,000 RPM when I'm basically at peak RPM, or where I'll end up shifting. Obviously I can get different pulleys for the supercharger itself, but the thing we'll run into is having enough wrap and friction to where we avoid slippage when you get to the higher boost levels. It just remains to be seen. So here we have our V-belt and serpentine pulleys driven together. I kept the machining tolerances pretty tight around here so that they key to one another. I actually took a little bit out of the face of the serpentine pulley in order for it to mate actually with the V-belt pulley. The back side is fairly tight. I'll be able to get a couple solid beads of weld there when the time comes, but with the two driven together we can see that they're pretty true to each other. There's no wobble in either one of them, which is going to be key when it comes to the longevity of this serpentine belt. If there was a little wobbled in the V-belt, it wouldn't bother me much, but preserving the alignment of the serpentine is going to be a big issue. We'll see. Well, so far we seem to be in a good place mechanically. It's all very close, very tight tolerances as far as belt clearance down through here. When I did put the tensioner on there and put a little bit of tension on the belt. The supercharger, the mounts themselves, as I guessed, wanted to flex forward. You know, it's not terribly thick steel, so you could actually see a pretty good kick on the top pulley headed down on the belt once there was some tension on it. So I went and threw in this extra brace here, and it seems to be doing the trick. There is still just a bit of flex when I lean into it, but hopefully that isn't enough to throw us off. You can see this little bright spot on the supercharger's pulley. I got a little carried away clearancing a couple things on the supercharger for the this pulley itself, and got my grinder into the supercharger pulley for about half the width of it, so I'm gonna have to order a new one. Still gonna go with the 3 1/3 inch pulley, as that seems to be, well, give me about my 1.5 pressure ratio. So, you know, roughly 7 pounds of boost. I did have to mangle some of the gussets that are cast into the water pump. This one down here, you can see it's broken off. Couldn't reach it with the grinder, so I just grabbed it with a pair of channel locks and made my clearance. The only other thing I'm concerned about is where the lower portion of the water pump, where it comes out, it's not touching, but it's real tight. If there's much vibration in this belt while it's working, we may see quite a bit of wear on this inside edge, but we'll just have to take it as it comes. We'll see what works, see what doesn't. I do have to make a little modification to my flying crank trigger mount. You can see it isn't quite lined up with the trigger itself, the crank mounted portion. So I'll probably just take this mount off and machine away maybe 1/8 inch or 3/16. It may register where it sits now, but I'd rather it was sitting a little closer to the center line of this trigger. We'll see. So, because of the machining we had to do in order to get the offset correct to align our V-belt and the serpentine belt for the supercharger, we had to do a little bit of modification to the flying crank trigger. Yeah. Which is this little guy here. This is, I suppose, the flying part of it. But in order for it to line up front to back, I had to take a little bit off of the mount, which wasn't terribly difficult. Just took probably 1/8 inch off of there, maybe 3/16, in order for it to line up front to back with the triggers, the what are they? Rare earth magnet triggers along here. So hopefully that works out for us, and we'll see how she acts. Okay, so here we are. With our supercharger in place, our tensioner in place, our braces, seems fairly solid. Time will only tell if this, well, the amount of tension on it when you actually run in the motor will cause us problem. The only thing I see maybe in the future is if you've ever seen the slow-mo on these belts, this slack side of the belt tends to wobble around pretty good, and it would end up making contact with our water pump at different places down through there. So I may end up having to put a kind of an idler in there just to limit the amount of wobbling that it does when it's running. But we're plumbed up with an oil supply. We've got our return coming from this side and down into actually the old mechanical fuel pump port that just has a plate to block it off for right now. It's obviously not ideal as far as draining, but I don't think it's nearly as important on these centrifugal units as it is on a turbocharger. So, and this was the lowest point I could put the drain at. There are a couple others, oddly enough. Right here by the supply is one, and another off on the side here, but that one where my drain is right now is the lowest drilled and tapped spot, so we'll hope that's enough to drain it away. There's no bearings like a turbo has to get fouled with too much oil, or, well, I suppose there's probably a seal in here somewhere. Maybe, hopefully we don't end up with oil on the, well, the compressor, in the compressor there at some point. Obviously our top radiator hose had to be modified in order to go around all this stuff, so I just hacked in a piece of exhaust pipe for right now. Who knows if this project will last long enough for that to show significant corrosion, but that's always a consideration, is using carbon steel in one of these in your coolant system, where it tends to tear up or cause a lot of corrosion. But obviously our charge piping isn't hooked up, and I don't have a filter on here, but we'll start her up and see. Well, we'll try and start it up and see how it acts. I've rewired the ignition. It was originally for the supercharger and everything. It was originally just running off the distributor, the mechanical advance off the distributor, with just a signal going to the fuel injection unit. But now that we've got the fuel injection unit, we'll be controlling the ignition advance curve. I'm using the flying crank trigger, which you can see down here, and I've had to modify in order to line up the pickup with the flying portion itself. But we're wired in, and I've made the modifications to the wiring harness so that ideally it should fire up for us. But we'll see. Hopefully none of my tools get rattled off into anything important. Our display here with all the pertinent information. Give the clutch a couple pumps here and see what she does. Not impressive. let's look around a bit and see where I've messed up here. So after a little bit of playing with it, it looks like the fuel injection system was flooding, causing the engine to flood. It wasn't the fuel injection system itself. I believe there are some notes in the installation guide that some ignition boxes will send a signal to the ECU that there's basically more RPM than what's actually going on when it's cranking. So it'll keep spraying fuel, and it just causes it to flood out real quick. I think I can trick it for right now by turning on the ignition and then hitting the power to the ECU or the fuel injection, but cranking on it before it actually shoots the primer shot, and then we'll give you a little earful. Maybe not. So we've got our charge piping all put together and plumbed, the blow-off valve mounted. You can see my welds are as ugly as always. I haven't ground any of them down because I'm not too proud to let everybody know how bad they can be. But hopefully they're airtight and don't explode under boost. Here we've got our little our other ugly little fix. Like I said the other day, when I was just idling this and wicking the throttle, we actually came off by one rib. The belt had moved outward, so in the name of limiting some of the movement on the belt, I've got these little roller bearings to limit its forward progress, and then I've got some nylon bushings there to limit the wobble when this side of the belt gets slack, which it does when you hit the throttle, because it's going to be tight on this side, and any slack is going to be in this length here. So we'll see how well those stand up to the belt's movement, and if this little guy will actually keep our belt from jumping off on us. I know it's more of a crutch than anything. I think if I had used 1/4 inch or maybe 5/16 plate for my bracketry, it would be quite a bit stiffer, and we probably wouldn't run into this problem here. What I believe we're looking at is when you hit the throttle, the tension on the drive side, I suppose you could call it, still draws the supercharger forward and down. So it cocks this pulley back and down, I suppose, allowing that misalignment there. So we'll see if this helps, and then there are other things I can do which I'm avoiding, namely being cutting pieces as opposed to having our spacers here with the bolts. Actually cutting a piece that reaches down closer to where the mounts bolt to the head, where it would be stiffer, and actually welding a piece from there up along here, and the same with this side here. Just a flat piece going down to the quick there by the bolt where it goes into the head, and then closer to this bolt here off at a diagonal. That would probably take all the flex out of it, but I like it being a little bit modular when I go to take it all apart. And if there is some adjustment, these can be shortened. Once you weld a piece in there, it's you're kind of stuck with what you got. So we'll see how this ugly little thing works. And yep. Well, for better or for worse, this is our supercharger setup. I realized that my crank pulley is actually an underdrive pulley, and it's not quite 6 inches across. So with the original 3.3 inch drive pulley, I just wasn't getting the RPMs on the impeller that I would eventually need. I was doing the math at about 6,000, which is past the horsepower peak. I would have been spinning about 35,000 on at the impeller, which is not bad, but throughout my curve I would have been underdriving it, not necessarily underdriven, but not driving the impeller fast enough. So got on Summit and actually just bought the smallest drive pulley they had, which is 2.6 inches. But with the decrease in diameter, I was running into my belts were starting to hit the water pump housing in an area that I couldn't necessarily clearance. So added a couple things. My tensioner was basically non-adjustable, so it was locked in there, and without measuring and getting the perfect size belt again, I was still going to be slack. So I've got this idler, which pushes the belt out and gives me clearance around the water pump. This one is semi-adjustable with basically just shims on the back side of the mount there to push it in or out. Right now it's nice and snug, and with as much belt wrap as I have on this pulley, I don't think I'll run into slippage issues. So that's about that. Started it up and took it down the road, and she I don't know how much boost I'm getting right now because I haven't done a full pull obviously, but it'll in first gear rolling about a 1/4 throttle, it'll just light up those rear tires. So it's going to take a little bit of foot modulation in order to get any kind of traction. My big old air cleaner, which takes a little bit of pressure pushing it down, and it fits under my big hood scoop. But that's it until we get a little further into the tuning.